Use the substitution x equals cosec theta to find the integral from root 2 to 2 of 1 over x squared times the square root of x squared minus 1 with respect to x. Given my answer to 3 significant figures. So whenever we do integration by substitution, the first most important thing I need to do is replace the dx. So I'm going to take my substitution and I'm going to differentiate that. So dx by d theta. Now when I differentiate cosec theta, you'd have this in your formula booklet. That will give me minus cosec theta cot theta. You do get given that in your formula book. I now want to rearrange that to make dx the subject. So multiply both sides by d theta. And there we go. So I can now substitute this in instead of the dx there. Next thing I want to do is worry about these limits. So when x is root 2, what's theta? Well, that's going to equal cosec theta, which cosec is the same thing as 1 over sine. So that's saying that sine theta equals 1 over root 2. Which, if I do sine inverse, I find that theta is going to be pi over 4. Now I'm going to say when x equals 2, what's the value of cosec theta? Again, well, that means that sine theta would be a half, so theta would be pi over 6. So we found that we've got the upper limit now in terms of theta is pi over 6. Our lower limit in terms of theta is pi over 4. So let's replace those. Now we're in the theta world. Upper limit pi over 6, lower limit pi over 4. 1 over the x squared. Well, x is cosec theta, so that is just going to be cosec squared theta. Then we have the square root of x squared minus 1. Again, x squared will be cosec squared theta in the theta world minus 1. And crucially, remember that the dx has been replaced by minus cosec theta cot theta d theta. Right, we have managed to move from the x world into the theta world. And hopefully now we're going to get some simplification. Right, so let's look at that denominator. That denominator is a bit messy. The square root in particular I'm looking at. Now, cosec squared theta minus 1, well, I remember the identity that I know that's cot squared theta plus 1 is cosec squared theta. So therefore, cosec squared theta minus 1 is cot squared theta. So I can replace that cosec squared theta minus 1 on the inside there with cot squared theta. I've still got the minus cosec theta cot theta d theta on the top there. Now the square root of the squared is going to cancel out. So that's just going to leave me with a denominator of cosec squared theta cot theta. On my numerator, I've got the 1 times the minus cosec theta cot theta d theta. Now I notice I've got some simplification that can happen here. The cot theta and the cot theta, they're going to cancel out. And also the cosec theta and one of those cosec squared thetas is going to cancel out as well. So that's going to leave me with the integral of minus 1 over cosec theta. Now, 1 over cosec is the same thing as sine. So I can change this 1 over cosec to be sine theta. Whilst I'm at it as well, I'm actually going to take that minus and use it to swap these limits around, just to make my life a little bit easier. So I've turned all of this complicated integral into just simply being the integral of sine from pi over 4 to pi over 6. Sine integrates to be minus cos. If I substitute pi over 4 in, cos pi over 4. I need a bit more space here just to finish this question off. So let me come back up here. So we'll have minus cos pi over 4 minus cos pi over 6. So we'll get cos pi over 4 is root 2 over 2. Minus, that's plus. Cos pi over 6 is root 2 over root 3 over 2, sorry. And it wants us to give this to three significant figures. So let's work this out on my calculator. So root 3 minus root 2 all divided by 2 is 0.159 to 3 significant figures. And there we go.